Hey guys, this is our math analysis project where we will be determining how to find the probability of winning a game in tennis. So the first thing that I'm going to do is explain to you how the scoring system in tennis works, because we're going to be referring to that a lot. So in tennis, you need to get 4 points in order to win one game. And you need to win 6 games in order to win one set. And you need 2 sets in order to win one match. So hopefully that wasn't too confusing. Hopefully you'll be able to follow along. And the data we're going to be analyzing today is 4 matches between me and Wasco's number 1, Peter Kitch. And we're going to be using just the games won per set 1 and 2. And we're going to find the probability of me winning a game for that specific match, for all 4 matches. So the way we did this is getting the number of games won that I won over the total amount of games played that match, and add those two, one for every set, and divide that by 2 in order to get our supposed probability of me winning a game per match. So as you can see, we're doing the work on the board, and on the top right we're gonna put these probabilities up there. So for the first match I had a 28% chance of winning a game. For our second match I had a 20% chance of winning a game, and for our third match I had a 33% chance of winning a game, and for the fourth match I had a 23% chance of winning a game. So what we're gonna do now is we're gonna add all 4 of those up and then divide by 2 to get the average probability of me winning a game just in general. And so keep in mind, we're not going to take into account fatigue and the mental weariness that comes from actually playing, because it's kind of impossible to actually measure that. So by the end of this, we determined that my average probability of winning a game is about 26%. So now we had to prove what we did was correct. And so the way we did this, and you're going to see it come up a little bit later, is we're going to draw a graph that we found that actually showed the direct correlation between the probability of winning a tennis point and the probability of winning the game. So something curious about this graph, if you notice it, and the probability of winning a point is going to be on the x-axis and the game on the y, is that even when you increase your chance of winning a point, even by just a little, like after 50%, then your chances of winning a game increase a lot, exponentially. And it just shows that even if you play someone a little bit better than you, the chances of you actually winning a game or the entire match is really low. And this is a phenomenon that only occurs in the game of tennis. So as you can see, that we checked where my 26% landed on the graph, and it should correlate with the 40% chance of me actually winning a point. So now, in order to prove that this is true, we used our formula based on Markov's chain that determines the probability of winning a game by inputting the probability of winning a point. So we're going to put in input 0.40 for all the p's, which would equal our supposed probability of winning a point. So right now we're just gonna show you the work that we did. So as you can see, at the end of it, we did get around 26%, which means our work was correct. So obviously this doesn't apply to every single sport, but this is definitely a way you can do this, at least for tennis, for all those tennis players out there, in order to determine the probability of someone winning a tennis game. Thank you. That is all.